Jupiter, the giant of our solar system. Hey everyone, welcome back to the channel. Today, we're diving into some mind-blowing discoveries coming straight from the largest planet in our solar system, Jupiter, a planet so massive that its gravitational force influences everything around it, shaping the very structure of our cosmic neighborhood. Beneath its thick swirling clouds lies a world of mystery, one we've only just begun to explore. For centuries, astronomers have been mesmerized by Jupiter's raging storms, colossal cyclones, and the mesmerizing Great Red Spot. But what lies beneath this chaotic atmosphere? What secrets has this gas giant been hiding for billions of years? Now, NASA's Juno mission is unlocking those secrets like never before. With each close pass, Juno sends back stunning, high-resolution images and crucial data, revealing phenomena no human has ever witnessed, from vast, intricate polar cyclones to deep atmospheric currents that defy expectations. Jupiter is proving to be more complex and more breathtaking than we ever imagined. But this is just the beginning. As Juno ventures deeper, the mysteries of Jupiter, and perhaps even the origins of our solar system, are finally coming into focus. Jupiter is no longer just a distant giant. It's a world waiting to be understood. Above Jupiter's poles, a mesmerizing ultraviolet glow sweeps across the sky. The auroras, powerful and untamed. These celestial lights hold the key to understanding Jupiter's internal structure and the immense forces shaping its swirling, stormy atmosphere. But these images are more than just breathtaking visuals. They are data, clues to some of the greatest mysteries of our solar system. What fuels Jupiter's immense magnetic field? How does its atmosphere transition from gas to a metallic ocean? And could this colossal planet have played a role in shaping the entire solar system as we know it? For decades, these questions have puzzled scientists. But now, with NASA's Juno mission, the answers may finally be within reach. Jupiter's magnetic field is the strongest of any planet, more than 20,000 times stronger than Earth's. This immense force not only shapes its own turbulent storms, but also crafts stunning auroras unlike anything seen before. These magnetic currents influence the very fabric of Jupiter's atmosphere, guiding the birth of dark ovals, mysterious storm systems that stretch across the planet's surface. With every passing moment, Juno unravels new secrets, bringing us closer than ever to understanding the gas giant that has guarded its mysteries for billions of years. Unlike the dazzling auroras of Earth, Jupiter's auroras remain hidden from the naked eye, only visible in ultraviolet light. Yet, beneath their invisible glow lies a force of unimaginable power. These auroras, like Earth's, are fueled by intense magnetic interactions. But on Jupiter, the scale is colossal. This immense energy surges through the planet's thick atmosphere, weaving a complex dance of charged particles and electric storms. But the reach of Jupiter's magnetic field extends far beyond its poles. It shapes vast radiation belts, traps charged particles in its grip, and even dictates the movement of its volcanic moon, Io. The forces at play here are unlike anything seen elsewhere in the solar system, raw, untamed, and reshaping our understanding of planetary magnetism. With every new discovery, Jupiter proves that it is more than just a gas giant. It is a planet of extremes where science meets the unknown, and where mysteries as old as the solar system itself are finally coming into focus. Jupiter is more than just the largest planet in our solar system. It is a living laboratory where powerful forces collide to shape an environment unlike any other. The planet's immense magnetosphere and its interactions with the surrounding space create a natural experiment for studying the physics of planetary atmospheres. For centuries, Jupiter's colossal storms have mesmerized scientists. The most famous of them all, the Great Red Spot, has raged for over 350 years, a swirling vortex of chaos large enough to engulf several Earths. But recent images from NASA's Juno spacecraft reveal a surprising truth. The storm is shrinking. Though still a monstrous force, its gradual fading hints at the ever-changing nature of Jupiter's atmosphere. Yet, the Great Red Spot is just the beginning. Beyond this iconic storm, Juno's discoveries are rewriting our understanding of the gas giant, from towering cyclones at the poles to deep, swirling jet streams hidden beneath the clouds. Jupiter is proving to be more dynamic and mysterious than we ever imagined. Every new image, every new data point takes us one step closer to unlocking the secrets of the solar system's giant. Jupiter's storms are more than just tempests. They are chaotic, ever-shifting masterpieces of nature. Among them, corrugated filamentary regions stand out. Intricate, thread-like clouds weaving through the planet's subpolar latitudes. These filaments are more than just turbulence. They mark zones where atmospheric layers clash and interact, creating structures unlike anything seen on Earth. But Jupiter's atmosphere is not an isolated entity. It is inextricably linked to its magnetic field. This immense force doesn't just shape the planet's auroras, it fuels its most extreme storms. Here, Earth-sized tempests are born from magnetic tornadoes, whirlwinds of energy that twist and spiral through the thick, volatile clouds. These storms are unlike anything we know, as distant from Earth's weather as Jupiter itself is from our world. As Juno peels back the layers of this gas giant, each discovery reveals a reality more dramatic, more violent, and more beautiful than we ever imagined. Jupiter is not just a planet. It is a realm of untamed forces where the laws of nature play out on an unimaginable scale. For decades, mysterious dark ovals have appeared in Jupiter's atmosphere, first captured in ultraviolet images by the Hubble Space Telescope in the late 1990s. Their origins remained unknown, a riddle hidden within the planet's chaotic storms. But now, thanks to recent discoveries, scientists have uncovered a stunning link between these dark formations and Jupiter's immense magnetic field, led by planetary scientist Troy Sabota and his team. Researchers have pieced together the mechanism behind these extraordinary atmospheric events. Each dark oval forms in Jupiter's polar regions, where the planet's powerful magnetic field lines converge and interact with streams of charged particles. These particles originate from Io's plasma torus, a colossal donut-shaped ring of volcanic material ejected by Jupiter's fiery moon, Io. As these charged particles race along the magnetic field lines, they collide with the planet's atmosphere, generating intense magnetic vortices, tornado-like structures of pure energy. These vortices spiral downward, plunging deep into Jupiter's stratosphere, where they churn up aerosols, creating a thick, swirling haze. In ultraviolet light, these turbulent zones appear as dark ovals, marking Jupiter's poles as a true magnetic tornado alley. Here, storms erupt with astonishing regularity. Hubble's annual imaging from 2015 to 2022 has revealed that these powerful storms occur nearly 75% of the time at Jupiter's southern pole, while at the northern pole, they appear more sporadically. adding yet another layer of mystery to the gas giant's ever-changing atmosphere. Jupiter's poles are more than just stormy regions. They are gateways to a realm of magnetic chaos, where the forces of nature collide on a scale unseen anywhere else in our solar system. At Jupiter's northern pole, colossal storms rage in ways unlike anything seen on Earth, while Earth's tornadoes are born from differences in temperature and pressure. Jupiter's polar storms are powered by something far more extreme: electromagnetic forces. Each vortex forms a tempest so massive that it could engulf the entire diameter of Earth within its swirling chaos. These storms are not just vast in size, they are dense, far denser than anything in Jupiter's surrounding atmosphere. Inside these dark ovals, a thick, churning haze forms, 50 times denser than the air around it. This suggests that aerosols are not merely lifted from deeper layers of the planet, but are being actively concentrated and spun by the immense vortex motion of these magnetic tornadoes. Yet, their true chemical composition remains unknown. What is certain, however, is that these dark, whirling storms provide a rare glimpse into the hidden mechanics of Jupiter's atmosphere, a place where the upper and lower layers of the planet interact in ways never seen before. Each new discovery peels back another layer of Jupiter's mysteries, bringing us closer to understanding how this gas giant operates, and perhaps even unlocking secrets about the formation of planets themselves. Jupiter's weather systems operate on a scale beyond anything seen on Earth. Its colossal storms, driven by unique and untamed forces, paint a stark contrast to the atmospheric phenomena we know. At first glance, one might assume that beneath Jupiter's swirling clouds lies a hidden surface, waiting to be discovered. But Jupiter is not like Earth. It has no solid ground, no familiar landscapes to stand upon. Instead, its structure is an endless transition from turbulent gas to swirling liquid, and possibly even to a dense, mysterious core buried in crushing depths. Understanding this internal structure is more than just unraveling Jupiter's secrets. It is key to deciphering the formation of gas giants and the very dynamics of our solar system, composed mostly of hydrogen and helium, the same elements that fuel the sun. Jupiter is a window into the early days of our cosmic neighborhood. Its upper atmosphere is a restless sea of ammonia and water clouds, mixed with traces of methane and exotic compounds. These elements, stirred by Jupiter's ferocious winds, create the vibrant bands and towering storms that streak across its surface. A breathtaking, yet chaotic masterpiece of nature. Beneath this dazzling display, however, lies a realm of unimaginable pressure and heat. A place where gas is compressed into a strange, liquid metallic hydrogen, forming an ocean unlike anything else in the solar system. Deeper still, the mystery of Jupiter's core remains unsolved. Is it a solid mass, a churning soup of heavy elements, or something even more exotic? Every discovery takes us one step closer to answering these questions, bringing us face to face with the raw forces that shape the solar system, and perhaps even the birth of planets like our own. From space, Jupiter's atmosphere is a mesmerizing display of swirling clouds and colossal storms. But as we descend deeper, the illusion of a surface fades. The atmosphere thickens, compresses, and transforms into something entirely different. Beneath its colorful cloud tops, Jupiter's atmosphere extends thousands of kilometers into an abyss of increasing density and pressure. What appears as a planet of gas is, in reality, an immense layered structure, shifting from turbulent skies to a thick, gaseous ocean that has never been seen by human eyes. Jupiter's very composition holds the secrets of the solar system's birth. Like the Sun, it is made mostly of hydrogen and helium, the fundamental building blocks of the universe. Jupiter and the Sun were born from the same primordial nebula, the ancient cosmic cloud that gave rise to everything we see today. But while the Sun ignited in a blaze of nuclear fusion, Jupiter remained just short of becoming a star, a failed sun, too massive to be a planet, yet not massive enough to shine. Instead, it has preserved the primordial gases of the early solar system, acting as a time capsule of our cosmic past. Studying Jupiter isn't just about understanding a single planet. It's about looking back in time, unlocking the very origins of our solar neighborhood, our world, and perhaps even the story of planetary formation across the universe. Beneath Jupiter's churning cloud tops, a hidden world exists, one of crushing pressure, scorching temperatures, and an ocean unlike anything in the solar system. As we plunge deeper, the weight of the atmosphere becomes unbearable. At a depth of 1,000 miles, 1,600 kilometers, the laws of physics begin to shift. Hydrogen, the most abundant element in the universe, no longer behaves like a gas. Instead, it slowly transforms into a liquid, flowing freely under immense pressure. But this transition isn't abrupt. It happens gradually, forming what scientists call the largest ocean in the solar system. Not an ocean of water, but an endless alien sea of liquid hydrogen. Here, the atmosphere is squeezed millions of times harder than the pressure at Earth's sea level. The crushing force is so extreme that hydrogen molecules are forced into a liquid state, creating an environment found nowhere else in our solar system. This vast ocean stretches tens of thousands of kilometers into the depths of Jupiter, a hidden realm of exotic physics where the very nature of matter is rewritten. But even this is only the beginning. Deeper still, the mysteries of Jupiter's metallic core await, holding the answers to the birth of giant planets and perhaps the very formation of our solar system itself. Deeper than any ocean, beyond the crushing depths of Jupiter's liquid hydrogen sea, lies a realm where matter itself is transformed. 20,000 miles, 32,000 kilometers, below the cloud tops, under pressures more than 2 million times greater than Earth's atmosphere, and temperatures exceeding 10,000 degrees Fahrenheit, 5,500 degrees Celsius. Hydrogen undergoes an extraordinary metamorphosis. Here, the relentless pressure squeezes hydrogen molecules so tightly that their electrons break free, turning the element into something almost unrecognizable, a liquid metal conducting electricity like molten iron. This bizarre substance, known as metallic hydrogen, is no ordinary liquid. It is the key to Jupiter's immense power. As free-moving electrons swirl within this layer, they create a planetary dynamo, generating the strongest magnetic field in the entire solar system, a force 20,000 times more powerful than Earth's. This magnetic might shapes Jupiter's very identity. It dictates the movement of charged particles, fuels blazing auroras at the poles, and extends a vast magnetic influence far beyond the planet itself, even affecting the solar wind. But even deeper lies the greatest mystery of all, Jupiter's core. Current models suggest it could be a dense mix of rocky and icy materials, infused with metallic elements, but no probe has ever seen it. No instrument has ever confirmed its existence. Does Jupiter have a true solid heart? Or is it something more enigmatic? A swirling, diffuse core, gradually dissolving into the planet's vast interior. For now, this question remains unanswered, locked beneath thousands of miles of crushing hydrogen seas, waiting for the next great discovery to unveil the truth. For decades, scientists imagined Jupiter's core as a solid, dense heart, hidden beneath layers of crushing pressure. But NASA's Juno mission has revealed a startling possibility. Jupiter's core may not be solid at all. Instead, it could be a diffuse, fuzzy region where rocky material is partially dissolved, blending into the surrounding metallic hydrogen. The pressure here is unimaginable, over 100 million times the pressure of Earth's atmosphere. The temperatures, a blistering 35,000 degrees Fahrenheit, 19,400 degrees Celsius, hotter than the surface of the sun. Under these extreme conditions, no spacecraft could survive to directly explore this region. Instead, Juno listens to Jupiter's gravity, using subtle shifts in its orbit to map the hidden depths. These gravitational whispers tell a story of violent impacts in Jupiter's past, perhaps even cataclysmic collisions with planetary embryos, reshaping its core over billions of years. Jupiter's enigmatic structure isn't just key to understanding this massive world. It provides vital clues about the birth of gas giants across the cosmos. If Jupiter's core is dissolving, could the same be true for exoplanets orbiting distant stars? But Jupiter's influence extends far beyond itself. Its immense gravitational field acts as a cosmic guardian, deflecting or capturing comets and asteroids that might otherwise threaten the inner solar system. Without Jupiter, Earth might have faced far more catastrophic collisions, perhaps even preventing life from ever emerging. Jupiter is not just a planet. It is a force of nature, a guardian of worlds, and a living relic of the solar system's violent origins. And yet, despite all we've uncovered, its greatest mysteries still remain. Jupiter, the king of planets, is not alone. Its gravitational might has drawn in a vast collection of 95 known moons, each with its own secrets, each telling a piece of the solar system's ancient story. Among them lies Amalthea, a small but enigmatic world, unlike any other in Jupiter's cosmic family. Discovered decades ago, Amalthea has intrigued scientists for generations. Unlike the grand ocean-bearing Europa or the volcanic inferno of Io, Amalthea stands apart, an irregular, potato-shaped moon, scarred by time and space. During Juno's 66th close pass of Jupiter, the spacecraft turned its gaze toward this tiny moon, capturing unprecedented images that reveal a surface battered by countless cosmic impacts. Craters, deep ridges, and jagged terrain tell the tale of a moon that has survived billions of years in Jupiter's gravitational grip, enduring an endless bombardment of asteroids and debris. Measuring just 52 miles, 84 kilometers in radius, Amalthea is a mere speck compared to Earth's moon. Its small size denies it the power of gravity to mold itself into a perfect sphere. Instead, it remains jagged, irregular, and ancient, more asteroid than moon. But Amalthea's story doesn't end with its shape. Juno's images suggest its surface may be covered in porous rock and even traces of water ice, hinting at an origin far from Jupiter itself. Was it once a drifting asteroid, captured by Jupiter's immense gravity? Or could it be a fragment of a long-lost world, shattered in a cosmic collision eons ago? Unlike many moons in our solar system, Amalthea orbits incredibly close to Jupiter, within a region where the planet's immense radiation belts rage with deadly energy. How has this fragile moon survived in such a hostile environment? Could its very existence provide insights into Jupiter's chaotic formation and the early history of our solar system? As Juno continues its voyage of discovery, each new image and measurement brings us closer to unraveling the mysteries of Jupiter's moon system. But Amalthea is just one of many, and Jupiter's family of moons still holds secrets yet to be revealed. Amalthea, the moon that feeds Jupiter's rings, Jupiter's immense gravitational grip, holds not only the gas giant itself, but a collection of mysterious moons, each playing a role in shaping the planet's dynamic system. Among them, Amalthea, a small battered world, orbits perilously close to its titanic parent, just 12,000 miles, 19,000 kilometers, above Jupiter's swirling clouds. His proximity places Amalthea within the planet's intense radiation belts, subjecting it to a relentless storm of high-energy particles. Time, this cosmic assault, may have altered its surface chemistry, causing the weathered, cratered landscape seen in recent images from Juno. But Amalthea is more than just a battered rock. It is also a contributor to Jupiter's ghostly ring system. When meteoroids crash into its surface, they eject debris into space, feeding the delicate gossamer rings that encircle the giant planet. This ongoing collision-driven process makes Amalthea and its fellow inner moons, Thebe, Adrastea, and Metis, key players in the evolution of Jupiter's rings, a relic from the dawn of the solar system. Amalthea's small size and irregular shape suggest that it may be a remnant of the early solar system, a survivor from a time when planets were still forming. Its unusual orbit raises fascinating questions. Did Amalthea form within Jupiter's primordial disk, a leftover fragment of the planet's chaotic birth? Or was it once a wandering asteroid, captured by Jupiter's immense gravity, forced into a tight, punishing orbit? Beyond Amalthea, Europa, and the search for life, Jupiter's moons are not just cold, lifeless worlds. Among them, Europa stands out, a frozen ocean world that may be one of the most promising places to search for extraterrestrial life. Beneath its icy shell, scientists believe a vast global ocean exists, kept liquid by tidal heating from Jupiter's gravitational pull. NASA's Europa Clipper mission, launched in October 2024, marks humanity's boldest step yet in the search for life beyond Earth. By 2030, the spacecraft will begin a series of close flybys, using advanced instruments to analyze Europa's ice shell, hidden ocean, and possibly even its seafloor. Jupiter's violent forces actually be nurturing life in the darkness beneath Europa's ice. As we push further into the mysteries of the gas giant's moon system, each new discovery reshapes our understanding of planetary formation, the potential for life, and the unseen forces shaping the universe itself. The quest for life, Europa, Zeus, and the next frontier. While Amalthea and Jupiter's rings offer fascinating insights into planetary dynamics, it is Europa, one of Jupiter's largest moons, that has captured the imagination of scientists and dreamers alike. Why? Because beneath its icy shell, Europa harbors a hidden ocean, one that contains twice the water of all Earth's oceans combined. This vast alien sea, kept liquid by tidal heating from Jupiter's immense gravity, could be home to hydrothermal vents, much like those found on Earth's ocean floors. On Earth, such vents teem with life, thriving in the darkness without sunlight. Could the same be true on Europa? NASA's Europa Clipper, a mission to find answers. In October 2024, NASA launched the Europa Clipper, a spacecraft dedicated to unraveling the secrets of this mysterious ocean world. By 2030, it will begin a series of close flybys, scanning Europa's ice shell for signs of liquid water, organic molecules, and energy sources that could sustain life. Radar instruments will pierce through the ice, mapping subsurface lakes and determining the thickness of the shell. Magnetometers will study the induced magnetic fields within Europa's salty ocean, helping scientists estimate its depth, salinity, and movement. Spectrometers will analyze surface materials, searching for organic compounds and chemical signatures of life-supporting processes. ESA's JUICE mission, exploring a system of icy worlds. Meanwhile, the European Space Agency's JUICE, Jupiter Icy Moons Explorer mission, launched in April 2023, is on its way to Jupiter. Arriving in 2031, it will focus primarily on Ganymede, the largest moon in the solar system, but will also study Europa and Callisto. What makes Ganymede special? Ganymede is the only moon known to generate its own magnetic field, and like Europa, it may also have a deep subsurface ocean. By analyzing the connections between these moons, JUICE will help scientists understand how icy worlds evolve and what conditions are needed for habitability. The final frontier. Are we alone? With these two ambitious missions, humanity is taking its boldest step yet in the search for extraterrestrial life. If Europa's hidden ocean does indeed harbor hydrothermal vents, and if those vents support even the simplest life forms, it would rewrite our understanding of life's existence in the universe. What if life isn't unique to Earth? What if, in the icy darkness of Jupiter's moons, we find our first neighbors beyond our world, beyond Earth, the hidden oceans of Jupiter's moons? As humanity peers deeper into the vast expanse of space, one of the most profound discoveries may be waiting beneath the frozen shells of Jupiter's moons. For centuries, astronomers believed liquid water, the foundation of life, was exclusive to Earth, but recent missions have shattered that belief, revealing that the coldest and most distant worlds may, in fact, be among the most promising places to find extraterrestrial life. Europa, the best bet for alien life. Among Jupiter's 95 confirmed moons, Europa stands out as the most likely candidate for life. Beneath its icy crust, a vast ocean, more than twice the volume of Earth's oceans combined, remains liquid thanks to the immense gravitational pull of Jupiter. This force creates tidal heating, generating enough energy to keep the ocean warm, despite Europa's freezing surface. But liquid water alone isn't enough. Could Europa's ocean contain the nutrients needed for life? Scientists have detected salts and organic molecules on Europa's surface, potentially originating from its hidden sea. Occasionally, water vapor plumes erupt from the ice, hinting at a dynamic, chemically rich environment below. If hydrothermal vents exist, like the ones on Earth's deep ocean floors, they could provide the energy necessary to support microbial life. Ganymede and Callisto. More oceans, more possibilities. Ganymede, the largest moon in the solar system, also harbors a deep subsurface ocean. However, its thick ice shell makes direct exploration challenging. Its magnetic field, a unique trait for a moon, interacts with Jupiter's own magnetic environment, influencing its mysterious internal ocean. Callisto, while less geologically active, may have one of the most stable subsurface oceans. Unlike Europa and Ganymede, which experience intense radiation and tidal forces, Callisto's more tranquil environment could offer a different path toward habitability. The next giant leap. Future missions to explore. These hidden worlds, NASA's Europa Clipper, arriving 2030, will scan Europa's ice shell, mapping water pockets and subsurface lakes. Will analyze magnetic field variations to determine ocean depth and salinity. Will study surface chemistry, looking for organic molecules and potential biosignatures. ESA's JUICE mission, arriving 2031, will focus on Ganymede, but also perform flybys of Europa and Callisto, equipped with radar systems to probe beneath the ice, revealing the structure of these alien oceans. The future, drilling into alien seas. The ultimate dream is to send a lander or robotic submarine capable of drilling through Europa's ice to reach its hidden ocean. Concepts include thermal drill probes that melt through the ice using nuclear-powered heat sources, autonomous submarines designed to explore the ocean and search for signs of life. If successful, this would be one of the most daring missions in human history. A journey into an alien sea to answer one of the most profound questions of all: Jupiter's mysterious moons and the search for life. Exploring Jupiter's oceanic worlds marks the beginning of a new era in the search for extraterrestrial life. Europa, Ganymede, and Callisto are not just icy moons. They are dynamic worlds with hidden oceans that may harbor life. While NASA's Europa Clipper and ESA's JUICE, Jupiter Icy Moons Explorer, missions are on their way to study these moons, we don't have to wait years to explore Europa. Thanks to NASA's Europa Trek platform, anyone with an internet connection can take a virtual tour of this alien world today. This interactive platform allows users to explore Europa's mysterious surface in incredible detail, using high-resolution images captured by the Voyager 2, Galileo, and Juno missions. Accessible at trek.nasa.gov, the site provides a comprehensive interactive map of the moon's surface. Exploring Europa virtually, the Europa Trek platform lets users zoom in on Europa's icy plains, ridges, and craters, analyze surface features in stunning detail, measure distances and heights, a valuable tool for scientists and educators. Take guided tours showcasing Europa's most intriguing landmarks. One of the most fascinating features of Europa's surface is the dark lines called linear. These are believed to be fractures in the moon's icy crust caused by Jupiter's immense gravitational forces. One of the longest, Baily's Linear, stretches for thousands of kilometers. The platform also highlights areas with chaotic terrain, where massive ice blocks seem to have broken apart and refrozen in new configurations. These regions may indicate past or ongoing activity beneath the ice, possibly linked to a subsurface ocean. Why does this matter? Europa's subsurface ocean is estimated to hold twice the volume of all Earth's oceans combined. Scientists believe that this ocean, hidden beneath a thick icy crust, interacts with the rocky mantle below. This could create hydrothermal vents similar to those found on Earth's ocean floors, potentially providing the energy and nutrients needed to sustain life. NASA's Europa Clipper mission, arriving in 2030, and ESA's JUICE mission, arriving in 2031, will study these oceans in greater detail. Using radar instruments and magnetic field analysis, these missions will map the ice shell, detect pockets of liquid water, and measure the ocean's salinity and dynamics. Future exploration. The data gathered by these missions will guide future landers or robotic submarines that could one day explore Europa's ocean directly. Instruments may drill through the ice or even dive into the liquid environment, bringing us closer to answering the ultimate question: could life exist beyond Earth? Until then, Europa Trek gives us an exciting way to explore this fascinating moon from the comfort of our own homes, Europa's surface, and the role of Jupiter in the solar system. One fascinating aspect of Europa is the scarcity of impact craters on its surface, indicating that it is geologically active. Unlike older, heavily cratered celestial bodies, Europa's surface appears relatively young. One prominent impact feature is Dire Crater, a multi-ring structure spanning 87 miles. Studying such craters provides insight into Europa's surface age and how it responds to impacts. As NASA's Europa Clipper and ESA's JUICE missions approach their targets, their high-resolution data will likely enhance platforms like EuropaTrek, adding new layers of information and improving our understanding of Europa's surface and interior. In the meantime, virtual exploration serves as a reminder of how technology brings the mysteries of the universe closer to us. Whether through a computer screen or instruments aboard a spacecraft, the quest for answers has already propelled humanity into a realm once thought unreachable. The unique role of Jupiter in our solar system. The solar system is unique. In many planetary systems, 20 to 30% of the time, the central star absorbs the planets orbiting around it. But if that's the case, why didn't this happen to us? The answer may lie in the largest and oldest planet of the solar system, Jupiter. It is possible that before Earth, Venus, and Mercury, other planets existed, but were destroyed by Jupiter, laying the foundation for the current solar system. In fact, what if Jupiter didn't even originate within our solar system? Some hypotheses suggest that Jupiter may have formed elsewhere and later migrated into our system, drastically shaping the planetary arrangement we see today. This movement could have influenced everything from the formation of Earth to the conditions necessary for life. As we continue to study Jupiter, its massive gravitational influence, its moons, and its potential interstellar origins, we may uncover new secrets about the formation of the solar system, and perhaps even the origins of life on Earth, Jupiter's composition and formation. Unraveling the mysteries. Jupiter, composed mostly of helium and hydrogen, has intrigued astronomers since its first observations in the 17th century. Despite centuries of study, many mysteries remain unsolved, particularly concerning its atmosphere, formation, and the iconic Great Red Spot, GRS. The Great Red Spot, a storm of the ages. One of Jupiter's most recognizable features is the Great Red Spot, GRS, an enormous anticyclone that has existed for at least 300 years. With wind speeds reaching 335 miles per hour, this storm has been gradually shrinking over time. In the 19th century, the GRS was estimated to be 25,500 miles wide. Today, it is only 10,250 miles wide, barely larger than Earth. The reason for this size reduction remains unknown, but scientists speculate that unknown atmospheric processes may be altering Jupiter's wind currents. The deep red color of the GRS is another unsolved puzzle. Some scientists believe it results from ammonium hydrosulfide, a colorless gas that turns red when exposed to solar UV radiation. NASA scientist Amy Simon suggests that there may be a link between wind speed and color intensity, with stronger winds leading to more vibrant red hues. Did Jupiter form far from the Sun? Beyond its storms, Jupiter's chemical composition raises questions about its origin. In addition to hydrogen and helium, its atmosphere contains heavy elements like nitrogen, argon, and xenon. However, these elements could only have formed at extremely low temperatures, suggesting that Jupiter may not have originated in its current position. Some scientists propose that Jupiter formed 4 times farther from the Sun before migrating inward to its present orbit. If true, this journey would have drastically reshaped the early solar system, possibly destroying other planets and influencing Earth's formation. How do gas giants like Jupiter form? The formation of gas giants follows a process similar to rocky planets, but with key differences: birth of a star and protoplanetary disk. After a star forms, leftover gas and dust form a rotating disk around it. This protoplanetary disk lasts for up to 10 million years, with 99% gas and 1% dust. Formation of planetesimals. Dust particles collide and stick together, forming larger objects called planetesimals. These grow into planets, asteroids, or moons, depending on available material. Why gas giants form far from their stars close to the star. Heavy elements like rock and metal form rocky planets, e.g., Earth, Venus, Mars. Farther from the star, lighter elements like gas accumulate, forming gas giants like Jupiter. A gas giant must have a massive solid core to attract and hold on to gas, an ongoing mystery. Scientists are still investigating how Jupiter acquired enough solid material to form its core before gas drifted away. Future missions and simulations may finally unlock the secrets of Jupiter's formation and migration. Jupiter, a key to understanding our solar system. Jupiter isn't just the largest planet in our solar system. It may have shaped the very structure of the planets we see today. Understanding Jupiter's formation, migration, and atmosphere could help scientists piece together the history of our solar system, and even provide clues about the formation of exoplanetary systems across the universe. Jupiter's migration and the Grand-Tak hypothesis. Astrophysicist Kobash Naka suggests that gas giants like Jupiter can build massive cores by collecting pebbles and ice particles that are pulled into the solar system by Neptune's orbit. These materials, along with vapors pushed by radiation, may have contributed to Jupiter's formation. However, there is also a possibility that gas giants are born outside their planetary system and later migrate inward. This idea forms the basis of the Grand-Tak hypothesis. What is the Grand-Tak hypothesis? Proposed by Kevin Walsh from the Southwest Research Institute in Boulder. The Grand-Tak hypothesis suggests that Jupiter originally formed much farther from the Sun, possibly at 20 astronomical units. As it gained mass, it began migrating toward the Sun, disrupting the early solar system. This movement could have shaped the asteroid belt and even influenced the formation of Mars. Astronomers at Lund University propose that Jupiter may have started as an icy asteroid in the outer solar system. After 2 to 3 million years, it accumulated a mass nearly equal to Earth's before shifting inward. Jupiter's journey to its current position. Researcher Sho Shibata explains that Jupiter, affected by gravitational forces, began spiraling toward the Sun. During this migration, it likely collected gas and solid materials, fueling its rapid growth. The migration process took about 700,000 years, and at some point, Jupiter may have occupied Mars's current position before settling into its present orbit. This massive shift in Jupiter's position would have dramatically reshaped the solar system. The clues. Jupiter's Trojan asteroids. One of the strongest pieces of evidence for the Grand-Tak hypothesis is the Jupiter Trojan asteroids. These asteroids travel in front of and behind Jupiter in its orbit. Scientists noticed that the front group of Trojans is twice as large as the back group. Computer simulations by Lund University suggest that this imbalance was caused by Jupiter's migration. This supports the idea that Jupiter once moved inward, dragging and trapping asteroids along the way. Did Jupiter originate from the Kuiper belt? Some astronomers believe that Jupiter's Trojan asteroids could have originally been part of the Kuiper belt, a region beyond Neptune filled with icy bodies. If true, this means that Jupiter's migration could have brought ancient solar system material closer to us, allowing scientists to study the early conditions of planetary formation without sending probes to deep space. Jupiter's migration reshaped the solar system. Jupiter's movement would have had major consequences, including disrupting the asteroid belt, creating a gap between rocky planets like Earth and gas giants, limiting Mars's growth, possibly explaining why Mars is smaller than expected, clearing out early planetary bodies, which may have prevented the formation of additional planets. The Grand Tack hypothesis remains one of the most compelling explanations for why our solar system looks the way it does today. Jupiter's past migrations may hold the key to understanding planetary evolution, not just in our solar system, but in exoplanetary systems across the universe. Jupiter, the guardian and architect of our solar system. Jupiter's immense influence has shaped and safeguarded our solar system in remarkable ways. Without its presence and gravitational effects, our planetary neighborhood might have been vastly different, possibly even hostile to life. Jupiter's role in Mars's development. Mars, despite its potential to grow larger, remained smaller than Earth. Instead of viewing this as a loss, it allowed Earth and Venus to thrive, ensuring a balanced planetary system. Jupiter's gravitational influence helped distribute material efficiently, shaping the planets we see today. Had Mars grown too large, it could have disrupted planetary orbits and altered conditions essential for Earth's development. Jupiter and the formation of the asteroid belt. The asteroid belt, rather than becoming a chaotic collision zone, became a stable region that provides valuable scientific insight into the early solar system. Jupiter's gravity prevented excessive planetary crowding, ensuring that Earth's orbit remained stable and habitable. This balance allowed planets like Earth to form without the risk of frequent catastrophic impacts. Instead of hindering planetary formation, Jupiter's role in the asteroid belt created a natural laboratory for studying our origins. Jupiter, the protector of Earth. Jupiter's massive gravity acts as a shield, diverting or absorbing many comets and asteroids that might otherwise threaten Earth. This protective effect reduces the frequency of catastrophic impacts, making Earth a safer place for life to evolve and thrive. The stability of the solar system, in part, is thanks to Jupiter's presence. Without Jupiter, Earth might have been bombarded by space debris, disrupting the evolution of life. A solar system designed for life. Jupiter's influence may have been intense, but it ultimately contributed to the perfect conditions for Earth. A stable planetary arrangement, protection from dangerous space objects, the right balance of planetary sizes for a harmonious system. Rather than a destroyer, Jupiter is a cosmic architect, ensuring the solar system remains balanced, stable, and capable of supporting life. Without Jupiter, Earth and humanity might not exist as we do. Jupiter, the cosmic guardian and catalyst for life. Jupiter's immense gravitational influence has not only shaped the structure of the solar system, but also played a crucial role in making Earth a habitable planet. What may seem like destructive events, such as the disruption of Mars's growth and the annihilation of earlier planets, actually contributed to the conditions necessary for life to emerge. Jupiter's role in bringing water to Earth, the origin of Earth's vast oceans, remains a mystery, but scientists believe that small asteroids, rich in ice, may have been the primary source of water. As Jupiter migrated through the solar system, it may have redirected these ice-filled asteroids toward Earth. This bombardment of icy bodies gradually covered 70% of Earth's surface with water, making life as we know it possible. Without Jupiter's influence, Earth might have remained a dry, barren rock, incapable of sustaining life. Jupiter, a possible catalyst for life. Some of the asteroids Jupiter sent toward Earth may have carried amino acids, the essential building blocks of proteins. These organic compounds are crucial for life, and their delivery by meteorites could have sparked the beginning of biological processes on Earth. Astronomer Phil Platt suggests that without this cosmic delivery system, life on Earth may not have had the right conditions to emerge. In a way, Jupiter didn't just shape the solar system, it may have helped plant the seeds of life itself. Jupiter, the great protector of Earth. Beyond shaping the solar system, Jupiter acts as a shield, diverting or absorbing dangerous asteroids and comets that could threaten Earth. Its massive gravity alters the trajectory of space objects, reducing the likelihood of catastrophic impacts on our planet. A striking example of this protection occurred in 1994 when comet Shoemaker-Levy 9 crashed into Jupiter instead of Earth. If the 1.2-mile-wide comet had reached our planet, it could have wiped out all life. Jupiter's presence significantly lowers the risk of mass extinctions, allowing life on Earth to evolve and flourish over billions of years. Jupiter, the unsung hero of our existence. While often viewed as a distant gas giant, Jupiter has played a direct role in Earth's survival and the emergence of life, brought essential water to Earth, possibly delivered the building blocks of life, shaped the solar system's structure, protected Earth from catastrophic impacts. Rather than a chaotic force, Jupiter is a guardian, a silent protector that has allowed life to exist and thrive on Earth. A positive Sare, Banadana, Jupiter, the guardian and architect of our solar system. Jupiter plays a vital role in shaping our solar system, protecting Earth from potential threats, while also influencing planetary formation and climate. Its presence has contributed to the conditions necessary for life and continues to shape our cosmic environment. Jupiter, a cosmic protector, deflecting dangerous asteroids. Jupiter's massive gravitational pull often redirects comets and asteroids away from Earth, reducing the risk of catastrophic impacts. Shielding the solar system. Without Jupiter, Earth would likely face more frequent asteroid collisions, making the evolution of life more challenging. Jupiter's presence ensures greater planetary stability, allowing life to flourish on Earth. Jupiter's role in Earth's climate stability. Jupiter helps maintain Earth's long-term climate balance by stabilizing its orbit. While its gravitational pull slightly changes Earth's orbit over tens of thousands of years, these cycles contribute to natural climate variations, fostering diverse ecosystems and promoting adaptation. This gradual and predictable change supports the evolution of life over long periods. Jupiter and the formation of our solar system. According to the Grantak hypothesis, Jupiter's early migration helped shape the solar system by organizing planetary orbits and redistributing materials. This movement may have delivered water-rich asteroids to Earth, contributing to the formation of oceans. Jupiter also helped clear excess debris, allowing the inner planets to form in a stable environment. Jupiter's influence has positively shaped the conditions necessary for the development of Earth and life. Jupiter, a window into the universe's mysteries. Ongoing missions like NASA's Lucy spacecraft and the James Webb Space Telescope are revealing new insights about Jupiter. These studies are helping scientists understand planetary formation, atmospheric dynamics, and the history of our solar system. Jupiter's powerful storms, including the Great Red Spot, provide valuable data on weather patterns that can even help us understand Earth's own atmospheric processes. By studying Jupiter, we gain deeper knowledge of the universe, advance in space exploration and scientific discovery. Jupiter, the silent guardian of life. Jupiter's presence has allowed Earth to develop as a habitable planet, providing protection, stability, and even the building blocks of life. As research continues, we will uncover even more ways in which this magnificent gas giant has shaped our existence for the better Jupiter. Unlocking the mysteries of a majestic giant, Jupiter continues to astonish scientists with its dynamic atmosphere, intense storms, and hidden complexities. Thanks to modern space missions, we are uncovering new insights that are reshaping our understanding of this colossal planet, revealing the secrets of the Great Red Spot. The James Webb Space Telescope, JWST, has provided groundbreaking observations of Jupiter's Great Red Spot, a massive storm that has been raging for over 300 years. Infrared imaging has unveiled intricate patterns above the storm, including dark arcs and bright spots, revealing an unexpected complexity in Jupiter's upper atmosphere. These findings suggest that Jupiter's atmosphere is far more dynamic than previously thought. The role of atmospheric gravity. Wave scientists have detected powerful atmospheric gravity waves which behave similarly to ocean waves, but on a much larger scale. These waves originate in Jupiter's turbulent lower atmosphere and travel upward, influencing climate patterns and radiation emissions. The waves affect the ionosphere, leading to variations in infrared light emissions caused by hydrogen interactions. This discovery deepens our knowledge of how gas giants regulate energy flow within their atmospheres. Jupiter's stunning auroras and volcanic influence. Jupiter's auroras are among the most powerful in the solar system, formed by interactions between its magnetic field and charged solar particles. Volcanic material from Io, Jupiter's most volcanically active moon, also contributes to this process, fueling the vibrant auroral displays. These interactions make Jupiter's atmosphere one of the most complex and active in our solar system. The future of Jupiter exploration. The European Space Agency's JUICE, Jupiter Icy Moons Explorer mission, launched in 2023, will further investigate Jupiter's atmosphere and its icy moons. Future studies will provide a deeper understanding of how Jupiter influences the solar system, including its effects on planetary formation and space weather. By continuing to explore Jupiter, we unlock clues about the formation of gas giants, planetary atmospheres, and even the potential for life on other worlds. Jupiter, a window into the universe. Jupiter remains one of the most fascinating and influential planets in our solar system. Every new discovery brings us closer to understanding the forces that shaped our cosmic neighborhood. As technology advances, we can expect even more remarkable revelations from this majestic gas giant. New discoveries from Jupiter, unraveling the mysteries of the gas giant. Jupiter, the largest planet in our solar system, continues to reveal astonishing secrets through ongoing space missions. Recent discoveries from NASA's Juno mission and the James Webb Space Telescope, JWST, have transformed our understanding of Jupiter's winds, internal structure, and atmospheric layers. Juno's breakthrough, cylindrical wind layers. NASA's Juno spacecraft has uncovered that Jupiter's powerful atmospheric winds do not spread in all directions as previously thought. Instead, they flow in cylindrical layers, aligned with the planet's axis of rotation. How was this discovered? Scientists analyzed Juno's radio signals, measuring tiny changes in the spacecraft's speed caused by Jupiter's gravitational field. Using advanced mathematical models, researchers mapped the deep atmospheric wind currents with 4 times higher precision than before. Key findings: Jupiter's zonal winds, observed in its colorful bands, penetrate deep into the planet, reaching 1,860 miles beneath the cloud tops. These winds remain unaffected by solid boundaries, unlike Earth's, where mountains and oceans shape weather patterns. The findings challenge old assumptions and provide new insights into gas giant atmosphere moving across Jupiter's equator. Key details: the jet stream is over 3,000 miles wide and travels at 320 miles per hour, twice the speed of a Category 5 hurricane on Earth. It is located 12 to 21 miles above Jupiter's cloud tops, in the lower stratosphere. Scientists observed wind shears, areas where wind speeds change rapidly, revealing complex interactions between atmospheric layers. Why is this important? This discovery helps scientists understand how Jupiter's atmosphere moves energy and affects its weather systems. It also provides insight into how gas giants evolve and behave in other planetary systems. Latest missions, like NASA's Juno mission and the James Webb Space Telescope, JWST, we are gaining a whole new understanding of this gas giant, from strange wind patterns to the planet's internal structure. Let's take a closer look at what we've uncovered so far. Juno's breakthrough, cylindrical wind layers. First up, let's talk about NASA's Juno spacecraft, which has completely changed our perception of Jupiter's atmospheric winds. For years, scientists thought Jupiter's winds spread out in all directions, but Juno's recent findings have revealed something totally unexpected. These winds flow in cylindrical layers, aligned with the planet's axis of rotation. How was this discovered? Juno used radio signals to measure tiny changes in its speed, caused by Jupiter's immense gravitational field. Using sophisticated mathematical models, scientists were able to map Jupiter's deep atmospheric winds with 4 times more precision than ever before. Key findings: Jupiter's famous zonal winds, the colorful bands you see on its surface, actually reach 1,860 miles beneath the cloud tops. These winds are not influenced by solid boundaries, like mountains and oceans on Earth, which means they flow unimpeded through the gas layers. This is something we've never seen before on any other planet. These discoveries challenge old assumptions and offer us incredible new insights into the atmospheres of gas giants. JWST's high-speed jet stream discovery. Next, let's talk about another game-changing discovery from the James Webb Space Telescope. JWST has spotted an incredibly fast jet stream moving across Jupiter's equator, and it's massive. Key details: this jet stream is over 3,000 miles wide and travels at a staggering 320 miles per hour. That's twice the speed of a Category 5 hurricane on Earth. It's located 12 to 21 miles above Jupiter's cloud tops in the lower stratosphere. Scientists also observed wind shears in this region, meaning areas where wind speeds rapidly change, giving us insight into the complex interactions between Jupiter's atmospheric layers. Why is this important? This discovery is huge because it helps scientists understand how energy moves through Jupiter's atmosphere and affects its weather systems. It also opens the door to understanding how gas giants like Jupiter evolve and behave in other planetary systems. Conclusion. So, to wrap it up, the findings from Juno and the James Webb Space Telescope are absolutely transforming our understanding of Jupiter. We're learning more about the planet's internal structure, its mysterious winds, and how its atmosphere works. These breakthroughs aren't just changing our knowledge of Jupiter. They're helping us unlock the secrets of gas giants across the universe.